question 1. Let me give me some room here. Okay, so although you don't have to do this, I suggest you do just because visually. So we know that here's money, right? The total depends on the number of visitors, so visitors will be my independent. So I'll write visitors over here. And the total cost is my dependent. So I know that here, zero visitors, I have no information of that. 1 visitor, 2 visitors, 3, 4, 5, 6, 7, 8. So I have information on 5 and 8. So when there's 5 visitors, Krabby sells 20 bucks right here. There's a point. And when there's 8 visitors, they sold 29 bucks. So those are the 2 points that I have right now. So let me write that down. 5 and 20, 8 and 29. So again, we're taking this, instead of me just giving you this problem like this and saying, hey, find the equation of the line, it's given it to you in the context of this problem. Same exact thing. So let's find the slope. And this would be my 2, so I'll do 29 minus 20 and 8 minus 5. And my slope is 9 over 3 or 3. So I can go to my equation. Y equals mx plus b. I know what m is, which is 3. So let me write this as a table as well. Here's a table. When there's 5 visitors, there's 20 bucks to be made. When there's 8 visitors, 29 bucks to be made. So what's the relation here? What's happening to 5 to get to 20? What's happening to 8 to get to 29? That's what we're looking for. So right now we know that the 5 is being multiplied by 3. And the 8 is being multiplied by 3. Right? Every input is being multiplied by 3. So, I mean, we can find out, right, that it's going to be plus 5. But let's do this here. Let's use a 0.520. Let's substitute. And if I substitute, I get 20 equals 3 times 5 plus b. 20 equals 15 plus b. And then if you do minus 15 on both sides, b equals 5. So there. So my full equation is y equals 3x plus 5. And we knew that already, right? Because if you take the 5, you multiply it by 3, you get 15. How do I adjust that to get to 20? You add 5. Take the 8 and multiply by 3, you get 24. How do I adjust it to get 29? I add 5. So we already knew that 5, but now we have a confirmation. So now I know that there's a y-intercept right here. Okay, and we can connect the dots. So again, and just to prove that to you, what happens when x equals 0? So when there's 0 visitors here, let's plug that in. Y equals 3 times 0 plus 5, and y equals 5. So when there's 0 visitors, there's 5 bucks in the vault. How do you explain that? Right? How do you explain that nobody came to buy anything, and there's still 5 bucks? Well, maybe that 5 bucks is the money that he leaves in the register for change. Maybe it's the 5 bucks that was from last night, right? Okay, or that he leaves. So if you ever open a store, you're always going to leave some money in your cash register, right? And that could be the explanation for that 5. Okay. Let's move on to 2. So again, all these repetitive, but again, just given in the different context. So this one is a gift card context, and they say, hey, gift card here, candy. I mean, the money is going to be dependent on the number of candy. So money is going to be my dependent, my y-axis, and candy is going to be my x-axis. So here's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know that when there are 4 pieces of candy, the gift card has $28 left. Right here. And then when he buys, and then after buying 10 pieces of candy, he has $25 left. Let's make that 25. Here are my 2 points. So I know that, of course, the more candy you buy, the less money you're gonna have on your gift card, right? So again, find the equation of the line. So let's use the 2 points, 4 and 28. The other point is 10 and 25. So this is my y2, x2, x1, y1. If you want to do it backwards, you can. So we do m equals 25 minus 28 over 10 minus 4, which gives us negative 3 over negative. Hang on a second. 10 minus 4 over 10 minus 4 is 6. So negative 3 over 6, which is negative a half. So that's my slope. I got my equation. We just found this guy over here, so let's substitute. Y equals negative a half. Oops. Plus b. Now we get to find b, the y-intercept. So we're looking for this guy right here. So here's my graph. I'm looking for this guy. Right? So this is my b. Well, pick a point, 4, 28, 10, and 25, whichever one you want. Let's just use 4 and 28. Let's substitute, we get 28 equals half of 4 plus b. 28, half of 4 is 2, or negative 2 plus b. We're going to add 2 to both sides, and b equals 30. So my y-intercept is 30. Now let's put that in a table so that maybe you can understand this a little bit better, or see a little bit better. Here's my x and the y. Here's my candy. Here's my money. When I buy 4 piece of candy, I have 28 bucks. When I have 10 pieces of candy, I have 25 bucks. And then let me add a 0. If I don't buy any candy, how much money do I have in my gift card? Well, 30. So that tells you that in the beginning, when you received your gift card and you didn't spend it, you had 30 bucks. Right, so my line looks like this, and it's decreasing, right? Because that's, sorry, I should connect the dots. Decreasing, because every time we buy candy, our balance gets lower and lower. 3. There you go for 3. Garfield, our cat. That after 2 lasagnas, so 0, and this is the lasagnas that he's gonna eat. So the weight of the cat, Garfield, depends on the lasagnas that he eats. So that would be my independent, and this would be my dependent, or my x. So 1, 2, Garfield was pretty famous for eating lasagnas. So after he ate 2 lasagnas, his weight was 35. So let's make this 10, 20, 30, 40. 10, 20, 30, 40, and 35 would be about here. So 2 lasagnas, he's at 35 pounds. And when he ate 4 lasagnas, he's at 39. So 39 would be just about here. What happens when he eats 0 lasagnas? Well, when he eats 0 lasagna, he should be somewhere, I don't know, somewhere around here, right? That makes sense, right? The cat has some weight, right? So, and that's what eventually we're going to need. And that's going to look like that. So we have the point 2 lasagnas, 35 pounds, and 4 lasagnas, 39 pounds. And again, we could have just given you this problem and said, hey, find the equation of the line that passes through these 2 points. But now we're giving you that same question and in the context of John and Garfield. So slope, x2, y2, x1, y1. So we do 39 minus 35 over 4 minus 2. And we get 4 over 2, which means 2. So the slope is 2. The rate of change is 2. So every time he eats a lasagna, he gains 2 pounds. That's pretty much. So let's go back to the equation. Y equals 2. Right, so my original equation should be in this format. So the slope is 2 times the number of lasagnas plus b. Right? So however many lasagnas you eat plus your original weight is your current weight. So let's find b. What was Garfield before he started eating the lasagnas? Well, pick a point. I'm just going to use 2 and 35. Let's substitute. 35 equals 2 times 2 plus b. 35 equals 4 plus b, minus 4 on both sides. B equals 31. So, before he started eating the lasagnas, at 0 lasagnas, how much did Garfield weigh? He weighed 31. What's my complete answer? Y equals 2x plus 31. So the rate of change is 2. 2 pounds for every lasagna plus his original weight. Or, this one. John is paid an overtime rate of $25 per hour after his basic wage of $600 per week. So this one's easy. So he gets $25 an hour plus the 600. So he works all week, Monday to Friday, from 8 to 6 p.m. Right, Monday through Friday. If that's all he does, he gets $600 bucks. But then sometimes he's asked to work a little bit more. I don't know, from 6 to 8 p.m. on Monday, 6 to 10 p.m. on Tuesday, etc. Overtime, right? Anything over what he's paid for originally was the $600. So that's it. For those overtime hours, he gets paid 25 bucks. Oh, I forgot. Therefore, there's not much to do. Number 5. Pete's checking account at the beginning of the month. So after 3 days, okay, so let's do days. And this is the money in his account. So this is my y-axis. This is my x-axis. And the beginning of the month, 0, right? The first day was 0. He has 180 bucks. After 3 days, so day 1, day 2, day 3. So he starts here. His checking account now is 172.50, which is right here. Now, that's a really bad graph, so let me just redo the graph. Let me put 180 over here. 172 is going to be right under. At the beginning of the month, starts here. After 3 days, 1, 2, 3, he's here. So it's going to be a straight line, but decreasing very slowly. Right? Like that. Straight line. We got your points. So your first point is 0 at the beginning. He has that much money, and then 3 days later he has 172.50. But we do know that slope is going to be negative. So when we do y2 minus y1, we're going to get a negative value. So let's call this y2, x1, y1, x1. So 172.50 minus 180. Sorry. Minus 180 over 3 minus 0. So we're going to get 750 over 3. And that's my slope. So let me go back on this side. Y equals 7.5 over 3x plus b. But guess what? In this particular problem, we don't need to select a point to find b. Do we already know what the y-intercept is? Y-intercept is right here. It crosses. This line crosses the y-axis, so it's actually y equals 7.5 over 3x plus 180. And actually, 7.5 divided by 3, sorry, I should have just simplified that to 2.5. Y equals 2.5x minus, negative, it should be negative by the way, negative 2.5x plus 180. Okay, so every day he's losing $2.50, $2.50, $2.50. That's this rate of change. 6, 7, 6. A new school has opened in the area. They don't have any books. But at the beginning, very, very beginning, 2010, So when you do your x-axis, and this is years, and this is the number of books, right? You don't write 2010 here. You actually write 0, right? And then and this will be how many years after 2010. So 2010 equals 0. It's gonna represent 0 on my number of years on my x-axis. And then in 2010 they had how many books? 500 books. So the library started like this. And then in 2014, 2011, 4 years later, or 2014, the library had 1,000 books. Write 1,000. So write this equation. How is it growing every year, right? How many books are being added every year? Okay, so we have 2 points, 0, 500. And the other point is 4, 1,000. x2, y2, x1, y1. So the slope is going to be 1,000 minus 500. And the other one is going to be 4 minus 0. You're going to get 500, over 4. And we're going to get 125. So every year the library is gaining 125 books. So y equals mx plus b. Y equals 125. That's a change, right? Every year. X represents the number of years. So every year we're adding 125 plus 125. And then plus b, the y-intercept. Again, the y-intercept we don't have to do because we already see it over here. It's 500. So if I asked you, think about this. If I asked you in 2011, how many books did the library have? Well, it would be 125 times 1 plus the 500 that they already had. How many books they have in 2012, which was 2 years after? Well, it'd be 2 times 125 plus 500. Okay, so there is my equation. Clear? Seven. All tickets to concert are the same price. Okay, so that's telling us that we already have a rate of change that's constant. The ticket adds a fixed order. A person who buys 5 tickets pays $5.93. So let's just create a table for this one. Here's my x and y. So if you put in x, you come out with 93. If you put in 3, you come out with 57. Right? We know it's not proportional. So hang on a second. This is 0. This is the number of tickets. My x-axis, and the y is my cost. We know it's not this, because if it was like this, there'd be no fee. So imagine that line just shifted over up a little bit. Okay, and this represents, so if you remember how I asked you, hey, how come at 0 tickets I already am paying something? Well, that's the fee. Okay, this one, the second line, let me just change colors. This line over here, pink line, if it was proportional, it would say, hey, 0 tickets, you pay $0. That makes sense, right? There's no fee. But unfortunately, that's not true in today's world. There is always some type of processing fee, and that's how they make some of their money. Okay. So we're looking at the blue line, right? So if I put 5, this the function, right? There's a relation. Now, if you buy 5 tickets, you end up paying 93. If you buy 3 tickets, you're paying 57. So let me put that. Let me take this guy because that's not relevant to our problem. And this is what you have right now. Let me erase this as well. So when you buy 5 tickets, you end up paying 93 bucks, and that's my point right here. You pay 3 tickets, you pay 57, and I'll put 57 over here. All right, so there's a line, and then what about when you pay 0 if you don't buy any tickets, you still are responsible for the processing fee, right? So your line's going to look like this. We have 2 points. You could have, we have more points, but in this case, we have 2 points. Let's use them. So 5 and 93, and the other point is 3 and 57. So let's do the y2, x2, find the slope. Let's just use the top. Those are my x2, so we get 93 minus 57 over 5 minus 3. And 93 minus 57 is 36. 36 over 2. Or 18. So, ta-da, we found the price of the tickets. So, y equals mx plus b. Y equals 18x, so every ticket's 18 plus, and here comes the fee. This time around, we have to find out what b is. It's not given because I don't know what the y-intercept is. So let me just write 57 should just be above here, right? So let's pick a point. I don't care. Let's pick 3 and 57. So let's use 3 and 57. Plug it in here. We get 57 equals 18 times 3. So when you buy 3 tickets, every ticket is 18 bucks, so that gives you 54 plus b, and if you subtract 54 from both sides, you get that b equals 3. So there's my processing fee, $3. So the 18 is, so the slope represents the price per ticket, and 3 is the, what do you call the processing fee. So y equals $18 per ticket, there we go, plus a $3 processing fee. Okay. Oof, what is this, 8? Why is 8 so long? 8 is an internet service. So again, charges $18 per month plus initial setup fee. One customer paid a total of $81 after 2 months of service fee. So here's what they're saying. They're saying that y, the total cost, is, if you want to figure that out, it's 18 per month times x plus some initial fee. That's what the first sentence says. And then we know that one customer, and I'll draw a graph, at 2 months, 0, 1, 2, 3, 4, what is that, 81, so let's go 20, 40, 60, 80. So we know that one customer, after 2 months, paid $81. So let me just draw it right there. That's 2 and 81. That's all the information that I have. I have half of my equation of line complete. I need to find b. Well, in order to find b, do I have a point? Yeah, I have a point. So I can use that point 2 and 81. Plug it in and figure it out. So 81 equals 18 times 2 plus b. 81 equals 36 plus b. Minus 36 minus 36. b equals 45. So there is your initial setup fee, $45. So y equals $18 per month plus the $45 fee. So if you were to sign up with this company, before you even start using the internet, they would charge you $45 as a setup fee, and then $18 per month. And then the final question is, so again, let me draw a table. We had a table, this is what we had. We had 2x and y, this was the total, this was the month. And we started by knowing that, hey, in 2 months I paid 81. Our next goal here is to find in 5 months how much will you pay. Okay, so that's this information we started with. So this is what your initial information started with, here and here. Well, now that I have that function, I can go y equals $18 for 5 months plus the $45 initial fee. So after 5 months, how much did I spend? 18 times 5 is 90 plus 45, y equals 135. So after 5 months, I spent 135. And then we have more. No. Okay, and again, you're given 2 points here, right? And says, so let's write this down. Year 1 at 35 kids, right here. And year 3 to 3, there were how many participants? 57. That's what I'm given right now. So, and if you want to write that as a table, you can say, hey, in 3 I get 35 function, right? And then in I have a relation where if you plug in 1, you get 35, and if you plug in 3, you get 57. So if you want to look at it as a graph, and look at it as a table, up to you. So in the fifth year, how many? You have 2 points, so let's use 1 and 35, and then what's the other one? 3 and 57. Okay, so again, y equals, and let's just use this as a 2's, and these are my 1's. So 57 minus 35 over 3 minus 1. So y equals, what is that? 15, 12, 15, no, 22, sorry. 22 over 2, and I didn't write y, sorry, hopefully you caught the mistake. This is slope. No. No. What in the world just happened? Alright, so let me go back again. Oh no. Wait. That's what happened. Okay. No. Sorry. Don't know what's going on. So, again, yeah, let me just use a table. X and Y, this is it says in year 1 there were 35 kids. In year 3 there were 57. And you're asked to find in year 5 how many kids do you think will participate? Well, 35, 135, 357. Let's find the function. So m equals 57 minus 35. I'm using this as my 2's, and 3 over 1. So we get 22 over 2, and m equals 11. So that tells me that every year we're adding 11. So let's find the complete equation. Y equals 11x plus b. Is there a b here? Let's use the point 1 and 35. So we get 35 equals 11 times 1 plus b. 35 equals 11 plus b. Minus 11 minus 11, that's a 0, and this is 24. So my final equation, y equals 11x plus 24. So how do we explain that in year 0, right, in year 0, there were already 24 kids interested. Maybe they didn't do anything the first year. Maybe that was just a sign up here, right? And then in the first year, it grew to 35. And then in year 3, it grew to 57. And in year 5, right, which is what we're trying to find out, let's figure out y equals 11 times 5 plus 24. That's 55. Y equals 79. So in year 5, we had 79 kids. So there. Right? That's my straight line, my linear relationship. We have one more? Yeah. So, I mean, you did half of it in class anyway. We have 2 more, please. Again, another problem. Just again, 5 minutes, so we know this is cost, and this is minutes. By now you know that time is always my independent. Money is my dependent, so this is my y, this is my x-axis. And then he says, hey, 5 minutes, you're going to pay $5.91. And then a 10-minute call, you're going to pay, says here, $10.86. All right. How are these two related? So again, if you want to write it like this as a table, right, x and y. So the function, the relationship that says if you put 5, you get 591 out. If you put 10, you get 1086 out. Right, that's what that says. How are they related? What if you spend $12? How many minutes will you get? Sorry, if you call for 12 minutes, how much will you pay? Well, let's use those 2 points. So m, I'm going to use these two and these two. Right, so 1086 minus 5.91 over 10 minus 5. Something over 5. 10.86 divided by 5.91. Oops. 10.86 minus 5.91. Something 495. 4.95 divided by 5. So our slope is 99 cents. So every minute is 99 cents. But if you remember, if you ever use a calling card, there's always a sneaky charge attached to it. So y equals 99 cents per minute plus some charge. Let's pick a point. Let's use this point here, and I'll highlight it. I'm going to use this point. Oops. Use that point here to substitute. Okay, so let's use 591. So 5.91 equals 0.99 times 5 plus b. So if you made 5 calls, right, it would cost you 5 times 0.99. It would cost you $4.95. But this is actually $4.95 plus b, 5.91. So let's subtract $4.95. So you're subtracting the price of the phone call. Whatever left over, it's your charge. So 5.91 minus 4.95 equals 96 cents. So every call has a sneaky charge, processing charge of 96 cents. So my equation is y equals 99 cents per call plus a 96-cent charge. You probably make more money on that charge than anything. So what if you make 12 calls? Well, if you 12-minute call, well, 12-minute call would be 99 cents, right? Times the 12 minutes, because that's how much you pay per minute. And then plus your charge. And y equals 0.99 times 12 plus 0.96, $12.84. And last question. You take a cab ride. Take a cab ride. Again, this is cost. This is what he's got. In this case, it's going to be miles. This is my x, right? This is my y. And it says that if you the cab ride from Dulles Airport to the hotel is 50 miles. So if you 15 miles is going to cost you $22.50. So that's, we have 1 point. 15 miles, you pay $20.50. Tricky question. We did one similar. I forget which number it is. So you have 2 points. You're given the slope here. Here is the rate of change. So y equals the rate of change. What are they charging you per mile? Well, every mile is going to be $1.50. That's what they said here. $1.50 times the number of miles plus maybe there is a charge, right? Just for getting on the car. So if you ever take a taxi, taxis make guaranteed money. I don't know, whatever it is, $4. I forget what it is. But the moment you step into the car and he turns or presses that button, you're already paying $4. And then on top of that, you pay a certain quantity per mile. This is what's happening here. So we know how much they're charging you per mile, 150. But what is that initial amount that they make, right? As soon as you hop in and sit on the cab. Well, we have half of the equation. Let's use this point right here. So 2250. Let's see. On his trip from the hotel to the airport, it was 150 times 15 because that's the price per mile, right? So 2250. Let's multiply 150 times 15. We get 2250. Oh, look at that. So in this case, unless I did something really wrong, b equals 0, there's no extra charge. So it's just 15, just $1.50 per mile. Is that what it is? That's so unusual. Let me just multiply this again. 1.5 times 15. No, it's 22.5. Well, lucky us. So for this particular trip, this particular cab company, every mile is $1.50, and that's it. So my equation is just 1.5x. It goes through the origin. There's no need for you to write plus 0. All right. It's not common, I'm going to tell you that much. So if it's $1.50 per mile, and you're going to travel for 7 miles, multiply that by 7. You get $10.50. Unless I did that really correctly. Blah, blah, blah. 25. Oh, I did it incorrectly. Oh. See, I used 2250. It's supposed to be 2550. So let me just do it again. Okay. Redo. Says miles, and this is total cost of your cab ride. So it says that if you travel 15 miles, your cost is $25.50. Right here. That's all we know. Okay, so let me write that point, 15, comma, 25.50. Now, y equals mx plus b. Do we know what the slope is, the rate of change? And we do here, right here. It's $1.50 per mile, $1.50 times x, which represents miles. So we can fill in $1.50 times x, the number of miles, plus b. Now we can go and see if there is what b is. So 2550 equals 1.5 times the 15 plus b. 1.5 times 15 equals 2250. So 2550 equals 2250 plus b. We're going to subtract 2250 from both sides. And b equals $3. So there we go. Explain that. How is it that you got into the car hasn't driven anywhere, and you're already charged $3? Well, there is that charge that I was talking to you about, right? That's how it helps out the cab driver, taxi driver make a little extra. Okay, so he guarantees that he makes a certain quantity, and that quantity in this particular problem is $3. So the moment you sit down, the car hasn't gone anywhere. He turns the machine. It already starts not at $0, but at $3. And then every mile after that, you're going to be charged $1.50. So your final equation equals $1.50 times the number of miles plus that initial $3. And that's the equation. And then you can plug in 7, which we'll do right now. Y equals 1.5 times 7 plus 3. Y equals, no idea, 1.5 times 3 equals plus 3. $13.50. So if you drove this cab as a passenger in this car for 7 miles, your total would be $13.50.